So we were looking at developing a rapid prediction for methane in pastures. We already run feed quality testing in Wagga. We've got a feed quality testing lab, and we were running some low methane emission pasture studies in Wagga as well, and we come up with the concept of trying to establish some rapid testing that would indicate the amount of methane production from some of these low methane pastures, and extending that out to other samples that we receive within the lab as well. So we've been looking at a lot of regular pastures that people would be looking at, but we've also been looking at some novel pastures as well with high levels of plant secondary compounds. Our research has shown that we definitely get lower methane with some of those pastures. So now drilling down to methods of estimating methane emissions from pastures. Respiration chambers are generally considered, as I say, the gold standard. I've got some methane collars here, but I haven't got green feeders, but they would fit somewhere in between options 2 and 3 there. Going to be quite accurate because they take into account some of the animal behaviour that goes along with feeding on pastures. But we were looking at the in vitro system because it's rapid, it's high volume. We're looking at analysing 1,000 odd samples. It's got good predictive ability, but it does have limitations in that it doesn't take into account things like rate of passage, some sort of interaction, I suppose, or palatability issues, something like that. It won't take that into account. So it does have its limitations. Basically, we take a gram of dried ground sample and we add some rumen fluid. We've got 3 steers there that we can get donated rumen fluid from. The rumen fluid contains bacteria and methanogens within it. They'll just basically simulate what goes on in the rumen. So we weigh out a gram of freeze-dried material into these jars, and we add some rumen fluid. We get rid of all the gas that's in there. We gas that out with nitrogen, and then we incubate that for 48 hours. So every 1 minute, a pressure and a temperature reading gets sent from the head of this unit to our computer. We line up about 40 of these things in a run, and we're able to measure the methane, carbon dioxide and total gas production at the end of that. This is an incubation over 48 hours, and you can see that some of those carbohydrates are converted really quickly, but we end up getting fairly stable over 48 hours. And then we produce an NIR calibration out of that. So this is an early stage calibration. All those colours represent different forage types, but we know we can get better if we separate out those forage types, which is where we're going in the next 12 months. In the pasture work, we've analysed 750 odd of those pastures now, and included some silages and hays within that as well. And some of the pastures will produce, say, 10 to 15 mils per gram of methane, whereas others will produce 45 or 50, so at least 3-fold the amount of methane per gram. I suppose any pastures or pasture mixes that are going to improve productivity are going to lead to lower emissions intensity. That's a pretty simple message, I suppose. Yeah, the shorter time that you can get livestock to market on higher productivity pastures, then the lower your intensities are going to be, that's for sure, and the better the outcome.